Hi, everyone, and welcome to the MLOps podcast. I'm Dean, your host, and today I have with me Yuval Gabay. Yuval is a DevOps turned MLOps engineer working at WSC Sports, where he's helped them build better infrastructure and automation for developing, training, and deploying models at really huge scales. He has vast experience in DevOps, and he built the MLOps infrastructure at WSC Sports from its infancy to what it is today. So, Yuval, thanks for joining me today.
Thanks for having me. Excited to be here.
Amazing. So, let's start at the beginning. Why and how did you get into MLOps?
Yeah, so I joined the WC about 4.5 years ago as a DevOps engineer. And as the time passed through, I did my bachelor's degree in computer science. And towards the end, I did another extra course in data science. And there I discovered the world of machine learning, just a bit of a taste of it. And that really fascinated me. Uh, Back then, I realized is something new in the world that might bring new technology and bring new capabilities.
Mhm.
Um, so I talked to some of the guys in my company, and from the algo team side, they also wanted somebody from the infrastructure to bring more knowledge to that domain on the team. And we created this role in WC, the first MLOps engineer role. And I'm excited to since then discover this field and domain, and I'm learning every day about the machine learning, artificial intelligence, and of course the MLOps world.
Amazing. So, I guess one thing that stands out to me in that story is that it seemed like very early on, people within your company knew that they wanted someone to take over MLOps. To me, like the timeline that you're mentioning is much sooner than what we heard in other places. So, I'm curious, like, first, what do you do at WC Sports, just in case someone doesn't know the company? And like, how did this come to be? Like, what were the main challenges that led them to want someone to do this full time?
Yeah, so with WC Sports, what we do is we analyze video for sports company broadcasters. Um, we work with the NBA, Premier Leagues, and 250 customers worldwide. They have streams of sport, let's say basketball or tennis or football. And what they actually want to do is create highlights,
Hmm.
and we give them this ability by analyzing the video and chopping the parts that the play-by-plays, and then we could determine which play do you need to see in your highlights. So we
Hmm.
rate them by their effect on the game, and then we can create automatically thousands of videos and publish them to our customers' social media. So we have a web-based application that our customers can utilize and play with. And this is what we do at scale, basically analyzing video, audio, data all at once, and bring this value to our customer. This is our bread and butter per se. We do a bit more stuff in content generation field,
Hmm.
which involves, for instance, cutting the video vertically. So pointing out the interesting part of the video and
Hmm.
cropping it to fit to a vertical, let's say a mobile device.
Interesting. And so, I guess maybe for those that sort of want a summary, if I were to see like on, I don't know, sometimes people share this on social media, the NBA games where you see like it's vertically filled, but it looks really professional. That's very likely sort of a result of WC Sports, right?
Yes, correct. So we do it for NBA, Premier League. many different sports, and in each and every sports, the focus area is different. Sometimes you
Mhm.
want to focus on the ball, sometimes you want to focus on the player, but it's not very easy task. But what we do is detecting the area that you want to focus on, and
Mhm.
we crop the screen to fit that mobile 9 by 16.
Interesting. And I guess just out of my personal curiosity, when you do this, does this happen like fully automatically? Like you have models that understand the focal points, or if I'm a user, I need to tell you like this is the interesting part, and then you track it or something like that.
We do it fully automatically. Sometimes
Nice.
we have like a double check maybe, but
Hmm.
our main goal is to do it fully automatically, almost near live. And then, yeah, as a user, you can get it maybe, I don't know, a few seconds after the play is made. And
Interesting.
yeah, so we worked very hard to make it fully automatically, because when it goes out to social media, it's done. You have to
Yeah.
be perfect.
Yeah, that's true. Is it also sort of a product of yours within the games? Like I've been to an NBA game or two, and they show on the screen, between plays, recaps and things like that. Is that also WC Sports or not yet?
So usually it's not WC Sports, it's the director. They have an
Hmm.
in-game director of the play, which he determines what you see during the game in the
Hmm.
screens there. But WC comes, it can be during the game, but you usually see that on social media, not on the stadium.
So like real time, like within a game. Yeah.
Yeah, correct. So our customer can decide if it's after LeBron made this crazy dunk, or after a quarter, or at the end of the game, he can decide whatever he wants based on automatic rules, or we can give him like a manual play-by-play catalog, which he can then drag and create a video.
Amazing. So okay, so that's amazing, and I can already sort of start to imagine some of the main challenges around MLOps with this. But like, yeah, I think that it seems like you are, as a company, sort of ahead of the game with respect to the sort of sophistication of your ML applications. What was like the first MLOps challenge that you had to handle when you started in the role?
Yeah, so about 2 years ago, Algo team already had, we have plenty of services running in production before I became an MLOps engineer, and we supported that within the DevOps team.
Hmm.
So when I came to the team as an MLOps engineer, I had already a live system going with a high scale. So I had to maintain it and make sure everything is still working. But I also inherited like a technical depth
Hmm.
uh, of just by DevOps thinking or misunderstanding um, this different field, and like saying, okay, it's just like a software. Let's put on the same resources on it.
Hmm.
So I had to rethink all this field, how we implement it. I was the engineering behind this, and also, as you know, MLOps also consists of the DevOps side. So as you can manage software, you also want to manage with the best practices of software to bring it to machine learning models. So the first thing I did is trying to figure out what we can do better. And we first tackled the DevOps aspect of our services, stuff like moving to Kubernetes, um, implementing a new configuration management, so we can have more control, more reposability over the thing. And yeah, so in the meantime, it was understanding what is MLOps, building this role, building the domain, figuring out what are the best practices, because this field is pretty new. And just like moving into this jungle of what to do, what to focus on, what is more important. And I'm a big believer of what is the most painful, then you deal with it first and you put the focus on first. And that's what we did. After a while, where things got a little bit settled down,
Hmm.
we could plan for the future for better, robust infrastructure that can lead us to grow.
Interesting. So, if I understand correctly, first, I guess to point out some of the things that you said, which I very much agree with. There's a lot to take from DevOps, like classic DevOps methodologies, to apply in MLOps, but you also need to understand the differences. And if you sort of adopt the mindset that it's just the same, there's this data thing and some model thing, and
Mhm.
that's fine, but it's software in the end. Then you're it's sort of like it might start out more or less the same, but then you might fall into sort of this like edge case, or not an edge case, something that seems like an edge case, but it's actually the standard case, mainly around like data scales, training scales, and the fact that like data is constantly changing and you need to handle it as on one hand, separate notion, but on the other hand, integrated into the source of your experiments.
Correct,
So
yeah.
that totally maps to to my and our experience at DagSub, I guess. There's one interesting thing that you said, which I also agree with, is sort of the product mentality of like going and asking your users, which in this case is the data science team, what are your main pain points, and then trying to solve those. And you're saying that the first thing that you found was sort of like related to scalability via Kubernetes
Yeah.
and configuration management. So can you share a bit more about those problems and how you solve them?
Yes, of course. So at first we had like a mixture of infrastructure to orchestrate our containers. We had some very little bit of services running on Kubernetes, and the most of it was something very similar to a virtual machine,
Mm-hmm.
um, which was not standardized, very difficult to maintain. So the first stuff we figure out we need to do is get all of our services under one roof. Did the de facto standard of orchestration for container, which is Kubernetes, and that would be a common ground for later development in terms of configuration management, deployment, manageability, and many more stuff we wanted to proceed with. But the first thing was to bring everything under one roof, under a standard way to manage services.
Mm-hmm.
And it was a bit tricky because we had also machine learning models. Some of them needs GPUs, this specialized hardware, and so we first figured out how to run GPUs under Kubernetes, and it's also pretty much new to run it under production, but it's feasible.
Mm-hmm.
And after we did our research, so how we bring all these containers under one roof, but as you know, Kubernetes is a shared container environment. So if one service is going crazy, then it eats up all the resources for the other resources. So we did it very, very carefully, defining the boundaries for each of the applications. And basically, it was a great success. I mean, it really led us to bring more development and more manageability into our services. Later on, which we can talk later, we brought up GitOps, another concept that very much is connected to Kubernetes, and this also brought us many steps forward.
Amazing. So two follow-up questions to that. One, um, was part of the standardization to define like standard, I don't know, like Docker files or container environments that sort of data scientists were I guess, incentivized or compelled to use in order to deploy models, or did you take a different approach for that?
Yeah, so my approach is to empower our team, our data science algorithm developer team. So I'm not as a guidance, I'm not gonna determine what is your framework. You can
Mm-hmm.
work at PyTorch, TensorFlow, whatever. You know your work best.
Mm-hmm.
But if you wanna jump into this ecosystem, then we have to define a certain API. And this API was, okay, you got your training data, every script that you run, it's okay. You can manage any way you want. But when you want to get it into the cluster, then you need to define a Docker file in a certain directory, a requirements file, um, this other prediction function.
Mm-hmm.
So then when you got this API that everybody needs to have a standard way, then it's much easier to bring application into the ecosystem. But on the higher level of framework, my concept is don't tell the data science team which framework to work on. Just be agnostic to it and build the tools around to be robust and scalable and dynamic to what the data science team needs. But of course, you have to determine a very specific API or stuff you agree with that you can have them on board.
Yeah. Yes, I couldn't agree more. I think that the the idea that you have sort of a standard contract for how a model is supposed to be packaged, and that contract should be relatively generic. So I like what you said. I think this is sort of very closely tied to what a lot of the sort of open source model deployment solutions like Seldon and MLflow and Bento all offer. So it usually goes around like uh, Dockerfile requirements and some Python that helps sort of load the model and predict.
Yeah.
I think that's usually the minimal sort of implementation that we see. I think that it's important to, I think, for me personally, it's important to hear people like you say that this is sort of the way you're approaching this internally as well. Because I think a lot of listeners are at a much earlier phase and they're not sure whether or not like maybe asking the data science team to do all those three things is also asking for too much and it needs to be even more generic. So I think that it is important to say like there needs to be some standardization, but as you said, we're not going to tell you how to do data science better than you know. So you should be able to do that however way you want, but the deployment part needs to sort of be an interface
Package,
that's agreed
yeah.
upon. Yeah. Um,
Absolutely, yeah.
so that's
And it's
great.
not even a hard request here. It's just like the minimal effort for the data science teams to bring their services. Just like as you said, like contract or a certain way of standardization.
Yeah, yeah, no, that makes a lot of sense. So I guess this is also yeah. We'll talk about GitOps in a second because I'm very interested in that. But I guess just because this is a good segue, like if there's someone listening who's starting out, so we already gave them one tip, which is standardize the deployment process the way you mentioned. Um, like how are you thinking about this, and what do you recommend for people that are just starting out now?
Yeah, so a lot of info in the web. Not everything is not very clear, but there is a lot of info. You have to
Yeah.
find the stuff that fits to you. But we live in an area where information is widely available. You also can interact with the ChatGPT and other LLMs that can help out in this field and bring knowledge. And also you can ask. I Early days I was talking to different teams and different companies, MLOps that were also maybe on the same phase, but this interaction brought up more ideas. And as we talked and we said, okay, people are dealing with the same concept pretty much. I discovered this as well when talking to colleagues. people are dealing with the same struggles or challenges. And so first, know this field, try to do as much as research as you can, and then go with the concept of building the tools. Um, for us, I am started out as a single MLOps engineer for almost a team of 15 or 16 people,
Mhm.
and it 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 would never scale if I had to do stuff manually or bring or do it like go with everyone hand by hand and do stuff. So you have to implement the right tools that can grow and scale with the team and be dynamic because you never know what tomorrow brings.
Mhm.
So yes, go for the standard stuff where you have a community around it. You can have support from colleagues or from people worldwide. I'm talking to Slack almost every day with Kubernetes and CNCF and Argo CD and many different products. Uh, so this field is pretty can overwhelm you because there is so many tools and some of them they do same stuff slightly different. So you have to figure out what you want to do, choose the right tools, and choose the stuff that there is community around it. That would be a good advice, I think, for somebody just starting to build the infrastructure.
I like that. I think that this plus the advice you said earlier, which is start with a problem that you have internally and not like a shiny tool that you want to add. I think that's also a great way to start. Um, and yeah, I think that one of the interesting things about talking to other people that are in similar situations is that sometimes we uh, like complicate between the specifics of the problem that we have and the generics that everyone dealing with this problem has, and talking to other people helps you separate the two. So if everyone else has the same problem, then there's probably a solution off the shelf that you could just use, and then you can also pinpoint what are the specific limitations or dimensions in which you need to solve for uniquely, and there you might want to actually sort of roll up your sleeves and start working
Yeah,
yourself. So yeah, those
correct.
are great tips. Yeah, go ahead.
I have to say I did it like I had to sometimes go to the point where okay, there is nothing really matching what I want. I have to build it on my own. But I try to do it on the smallest part possible, the smallest module component possible. And for the other part, trying to integrate tools together. And when you work with the standard applications and tools, it's much easier because usually these tools integrate with each other.
Yeah, yeah. I guess to share a specific story, I think that this is sort of an ongoing challenge that you have because, again, I think I've said this a bunch of times on this podcast. We are sort of variations of engineers, whether you're an MLOps engineer or a data scientist or whatever. It's all close to the school of thought of we like to build things, and so it's very tempting to whatever you have as a problem to just go ahead and build something from scratch. I was working over the last couple of weeks. One of the things I was working on was writing some code that converts between two formats that are relatively complex. And I started to implement everything. And I realized at some point that I'm writing a lot of code, and I would expect this to be something that I can just use. And then I spoke with a friend who's also my co-founder, so I have an excuse to nag at him. And he told me like there's no way that there's nothing that you can just modify a bit. And then we did a bit of extra searching, and instead of writing a class from scratch, I inherited an existing class and changed two or three tiny functions, and everything works, right? So it's much more maintainable because there's another class
Yeah,
I'm inheriting which I don't need to manage. And so I think this is a tiny example. Everyone listening is probably dealing with much larger problems, but I think it's important to notice, like even after you've done this a few times, you might be tempted to get back to, oh, the third problem I'm going to build from scratch. So it's important to sort of be reminded.
yeah. You have to first start your research online, try to find, okay, is anybody came across this?
Hmm.
Ask somebody, talk to Slack with the colleagues and stuff, and then your last resort should be implemented on your own, because as you said, it comes with the maintenance of every script that we write is due to break somewhere in the future, and you have to maintain it. And when you have a community around the tool, then it's much easier. The knowledge, I can say I opened a few issues to GitHub, to Argo CD on GitHub, and uh, implemented features. So the community really helps you moving forward and maintain this very complex domain.
Yeah, I totally agree. So, if we're talking about GitHub and GitOps for machine learning or for MLOps. So, how did you like get into that? What was the main problem that you decided GitOps might be a good solution for, and how did that sort of, as you said, move you a few steps forward?
Yeah, so on my team, um, we have, as I said, um, a few, let's say, 30 services,
Hmm.
applications running in different environments. So it became a hassle, pretty hard to manage everything, especially when you have everything in Kubernetes and all these different YAML files. It can really overwhelm you, many different lines of code. So what we did is first bring everything to like a boilerplate.
Hmm.
So keeping, as we say, the YAMLs dry, which is don't repeat yourself. So it's easier to maintain. You have to change maybe a little bit of code somewhere, and it affects everything. And it's more easy to manage everything. So as we did that and started to working with Helm and customize and bring all these different applications into a boilerplate of YAMLs, then okay, so how we maintain it? I remember doing with one other guy of my team, doing like manual stuff on the clusters, everybody on his own PC, and then as you can imagine, we override each other. So we came across this challenge and we said, okay, there must be a solution for it. And then by researching it and discovering on the internet that this concept of GitOps,
Hmm.
the concept of GitOps says you have Git managing all your resources as a single source of truth, and then there is no way other team members can break stuff because everything has to go through the process of Git and pull request, and you can blame people. I'm kidding. You can know your history and trace back changes, and also you can implement testing and everything that Git has to offer.
Hmm.
So we we started working on bringing our infrastructure to the point where everything is under Algo CD as a GitOps tool, and we manage
Hmm.
everything from Git using Helm for services, and then for the different environment, let's say development, staging, production, we use Customize, which can overlay the same deployment but change very little stuff between environments.
Hmm.
So the point we are now, I think it changed my life in so many ways. It's only working through this GitOps concept. And this is true for every software project. But in machine learning, there is an extra step you have to take for managing the models and configs, which is models. You can use tools like a model registry.
Hmm.
And for configs, we utilize the Kubernetes config maps
Okay.
also as an GitOps. And we also brought this one step further using Hydra, which is a package under Meta, which you can inherit different config files and also change only a bit. So let's say I have a service that has five different environments which is deployed to, and between each environment, the only difference is the something very little. So again, you don't have to copy paste everything, which would be very hard to maintain. You can only specify one source and then inherit this source and only change this specific line you want. And
Hmm.
this became very important tool for us and really help us manage all this jungle.
So that's really interesting. Was there, so you mentioned sort of, obviously there's the software, there's the configuration, there's the sort of ML model configuration. Um, was there anything you needed to change or think about with respect to data in the realm of GitOps, or was that more or less straightforward?
So in the realm of data, we treated earlier on the training phase.
Hmm.
So we manage our data under ClearML. So we
Hmm.
have these data sets that we keep that everyone can see what's in the data set. You can have statistics on the data set. You can have version of it. And then when you have a model, you can trace back what the data your model has been trained on. And you can, of course, slice it the way you want. You can have different tags for testing and different tags for development or evaluations. So then you have a standard way you can manage data. In
Hmm.
terms of inference, we are not quite there yet. We are thinking about feature stores and different concept of managing our input data on inference, but
Hmm.
it's we are still researching this.
Interesting. And so I guess if you had to choose one, what would you say is the hardest part of MLOps from your current experience?
So I think it's very complex to know all these different tools and the nature of machine learning models itself. It's way more complex than managing a software project because you have all these different variables. It starts from the compute when you have GPUs and CPUs, and GPUs require drivers, and then you have these frameworks that can be very different from each other, and then you have this model which also you have to manage and know where this model came from, what is data, what was the parameter that brought this artifact. And after you have all of this and you deploy it to production, it never ends there. You have to monitor your machine learning models and be aware of drift and the data suddenly change. And this whole process or workflow is very different than software, and it requires more attention, more expertise in the field.
Hmm.
And I think the part we are bit challenging is how would you know your model is not doing well? And if it's not doing well, then what you do? You start a continual learning process based on what? And then you have, let's say, everything was in you have a model retrained. So is it better than the other model? So all this question is very hard to determine, especially for all these applications that we run. I'm talking about having this fully automatically workflow. It can
Sure.
take a lot of time to create it, but even if you create it good, then you have to be very careful,
Hmm.
and and you have to be very expert on the field of what this model does and how would it be to retrain it, what would be the outcome of it, and how do I make sure this model performs better than the old one.
Interesting. Yeah. So those are definitely big challenges that we hear in other places as well. I guess maybe in a self-serving capacity, I'm curious, do you um, transmit data back from production into your training data, or is that something that you can't do because of, I don't know, data sensitivity? I'm guessing it's not sensitive because you put it out on social media, but yeah, like how does that looping back from production into training?
Yeah, so we have our BI infrastructure that aggregates the predictions from our models,
Hmm.
and then we can detect if a model is outperforming or is not performing very well on
Hmm.
we can pinpoint this certain data that is not working good on, and then it's on the data science team to determine what to do, how to retrain it. Currently we do it not fully manually, but the action of deciding to retrain a model is manually determined by the data science team, and then the process is automatically.
Yeah,
But
sure.
we want to go to a point where we have all this cycle working automatically.
Interesting.
Uh,
So also like automatic retraining, like there's a algorithm that decides when to retrain.
yes, correct. And it's some of our application is very hard to determine if it's good or not. So let's say we talked earlier about this model that cropping the um, your stream into a mobile adapted stream.
Hmm.
So how would you know it performs better than the one before? The metrics here, evaluations are uh, visual and not sometimes can be determined by a metric or a algorithm.
Yeah, that's true. I guess to share the way we think about this, and I don't know if this is something that you've implemented. In many of these cases, the it's not. I guess the buzzword right now that everyone likes to talk about is sort of RLHF. Maybe that's the extreme sample of this. But what we have seen, and we're actually like now, this is sort of on my mind. We're building something that I guess by the time this episode is launched, everyone will hear about DAG's Up Data Engine. So we're going to launch a system which helps you manage data in that context. And the way we've seen our customers and our users think about this is you transmit the information back and you can create pairs where it's two models that are running on the same data point or video in your case. And then you send those pairs to annotators and ask them to rank which one is better. And that's how you define the metric. So there is a human in the loop,
Hmm.
but you're basically only outsourcing the decision about whether or not the model is good. Everything else can be automated, like as you said, like there's a threshold and everything. I know that some larger organizations do this. Can't share names, I guess, on the podcast, but I think this is relatively effective and relatively automatable, with the caveat of you still. I'm still not familiar with a machine learning model that does the ranking automatically, but maybe that's also possible.
Yeah, I think it is possible. It requires the underlying infrastructure workflows to make this work, as
Hmm.
well as the concepts of when to train and what exactly you do, which parameters and what data to collect. Is it only newer data? Is it take this data from this certain client? Um, yeah, so I think we are scratching the surface there, but
Yeah.
still work to be done there. But that's a very interesting topic to me.
Yeah, yeah, I agree. Okay, so one small question, and then maybe we'll move to the sort of higher level questions. But you shared sort of this interesting case where you started as a DevOps engineer who was responsible for sort of the deployment or maintaining models in production. And then you transitioned on into the data science side as an MLOps engineer, where you sort of took on those responsibilities, but maybe deepened into the ML field. What Who would you say is supposed to be responsible for taking models into production?
Yeah, so I think that the MLOps engineer should have the tools, the concepts, the best practices of how to deploy a model. For example, uh, as we did, we gave our team the ability to deploy a model on different strategies. Let's say A/B testing,
Mm-hmm.
Canary, Shadow. So it's on the MLOps engineer to bring the tools, to bring the practices to do that. But I think the responsible team should be the data science team to take these models, to utilize the tools, and wrap this model service application into the different environment, including production, and then also maintain it, make sure it runs well. But the MLOps engineer should be setting the tone for that because he has the domain expertise on that. And to make it, as we said earlier, as much as robust, scalable, and dynamic for different applications to utilize.
Okay, so let me ask you this in a more in a harder question way. When the model breaks in the middle of the night, who should wake up?
Unfortunately, I think the data science team won't wake up. They sleep very well, probably when the model is done.
Fair enough.
But yeah, in this specific area, it's different. I was talking to a colleague the other day, and we said, okay, then if the data science the developer is waking up in the middle of the night, what he should be doing? Should he retrain his model? Of course not. Then in machine learning models, the bug per se is different because sometimes it's not related to a software bug. The model predicts something unexpected, then not always you have to do you have something to do with it,
Mm-hmm.
especially not in an urgent way. Um, so if you make sure your model won't reach into this software bug where it actually breaks and not even predicting anything, then of course you have to wake up and deal with it. Probably an MLOps engineer would be dealing with it first. But if you have an ML problem where your model is not performing well, usually it's not something very drastic that requires immediate attention. Then, uh, then our team is trying to draw this. What should you do? But it usually it's an effort that would be um, very different than like urgently. You have
Yeah.
to build your data again. You have to try to explain why the model didn't predict this well, and to see if there is the pattern. If there isn't a pattern, then probably nobody's gonna take care of it until there is like a pattern that you can say, okay, in this specific client, the model is uh, is having difficulties, then the data science can retrain it or mitigate it.
Mm-hmm.
So as we seen, the first responders are the MLOps engineer, the DevOps engineers. They usually are the ones which wake up at the middle of the night. Uh, Fortunately, it's not happening so much.
Yeah,
You have to take care of it. You have to put your defenses to make sure it never happens. And if it does, then you have to deal with it. I have to say, done it a few times. I think it's part of the job.
sure. Yeah, I think that the interesting point to me here is that if people are transitioning from software or classic DevOps to MLOps and data science, the time scales, as you say, are fundamentally different, and that takes time for people to understand. Like you can't really shoehorn sort of support and I don't know, like SLA nines into ML models because it fails in a fundamentally different way most times. And so when people talk about monitoring, it's more like understanding that there is a problem and what that problem looks like, and less like getting an alert 3 minutes after the model has drifted or something like that, because that concept
Yeah.
is, yeah, it doesn't exactly work that way.
Yeah,
Um,
you have to take care of the everything before, as we said. So make sure the deployment is running, and if it's phased, then you have a failover mechanism and stuff like this. But if you got all of that sorted, then if you got an ML problem, then it's usually something that you would address later and in more relaxed way. And sometimes it's not an easy fix you can implement.
yeah, sometimes things, yeah, just are fundamental property of reality changing, and it just takes time.
Yeah.
Um, Okay, so a few high level questions. Everyone is talking about large language models. How are you thinking about them? How they're going to affect your work and the company's product?
Yeah, so I think everybody's heard about ChatGPT, generative AI, Midjourney, all of these new exciting models. I think we we've seen the power it can bring to almost everything that we do. So of course, within the company, we are looking into ways we can utilize this technology to our benefit. And I think it would bring a way more robust way to bring, um, first of all, understanding images, videos, audios, let's say action detection would be maybe in the near future could be much easier task. Um, we've seen models, large language models that can get a picture and understand what you see in it and
Hmm.
transcribe it and caption it. So, of course, it could bring opportunities to our world in terms of ML and the field of generative AI, where you can create images from text, from prompts. So we're still trying to figure out what are the best ways to utilize this technology. In terms of the MLOps, I think it's also another domain that I have to be
You
involved
need to
in.
learn. Yeah.
Yeah, you need to learn and be involved in because the nature of these models is different. It usually brings infrastructure changes and infrastructure more demanding because these large language models are emphasis on large. They require more compute. When you want to train them, you have to get a lot of data into your system, how you manage the data, how you build your infrastructure to be as robust as throughput all this data into models, how eventually you're gonna run the model in a way that would fit thousands of users. It's a question. I think it's also something would affect the MLOps domain.
Yeah, I agree. I think that there's another thing, which is if you're not working with your own LLMs but using an external one, then there's this new paradigm where a model stops being something that's internal to the organization but needs to be sort of managed as a gateway API, something like that. It does emphasize the data management part in my mind, but there
Mhm.
is this paradigm shift in models not sort of being owned by the company using them, which I think is going to be interesting, both with respect to data science and MLOps. But yeah, the
Yeah.
so given where the hype is and where it isn't, what do you think is the most interesting topic in machine learning right now, and what's the most interesting topic in MLOps?
Yeah, I have to say, the last year regarding generative AI, it's very much interesting. This technology, I think, is starting to be embedded into our day-to-day lives, and I think this also opened the gate for the larger audience of what machine learning is, what is the meaning of this. Some people, you know, it worked, but it never really touched their life. So now they see this field right at their face, and they realize everything we have we've been doing. Most of the companies we have services from are doing something in the machine learning world. We can see it at factories, entertainment companies, etc., etc. And so the transition from like a models which can do a specific task into foundation models and larger models which could do many different type of tasks. I think it's very exciting to see, and I think it's going to be affecting the ML world and also the MLOps world um, for a few years to come until we have a next leap in technology.
Some would say if we have the next leap in technology, but yeah, I
The
like that.
nature of of this field is it's going to happen. Another leap. It's going to probably happen. Uh, if we talked 2 years ago about creating images from prompts, I think it would be sound like a dream, but now we see these models that can do it in high definition, very um, complex way, and the outcomes it's sometimes it's outstanding.
Yeah, I agree. I think that the well, I mean, I guess there is an element of hype to LLMs, but there's also like fundamentally we see this everywhere, and I think that the point that you made I really agree with, which is before this ML, data science, whatever, was something that people did in companies and it didn't affect most people, maybe indirectly, like you knew that a product that you're using uses something, whatever, but now you have sort of unintermediated access to ML or AI. I also think that one of the changes resulting from this is that data scientists and ML people are no longer shy about saying that they're working on AI, which I felt was a derogatory term before the beginning of this year. So that's also interesting. But I think the fact that I don't know, you could go and sit with your aunt and uncle and grandparents and show them ChatGPT and they can interact with it is something that you didn't really have before, and that's same for Midjourney. That's really amazing. Um, so maybe on the other end of the spectrum, tell me something that you think is you believe is true, but few people agree with in the fields of machine learning, MLOps, or whatever. Yeah.
Yeah, so um, I think also in my company, I spend some time explaining what is MLOps exactly, uh, because most of people think, okay, it's just a DevOps, right, with a fancy name. So do I. So did I. 2 years ago,
Hmm.
when we first built this role. But slowly, I figured out, okay, this field has more of different approaches, different flows, different practices that MLOps needs to address in software. And this comes from the nature of machine learning models, which is totally different than software. It's I like to call it an organic matter, because a model, it's consists of the data, the parameters, the code is has been trained on, and
Sure.
a model can easily, let's say, break or have a drift, because it's not a software, it's not a set of commands that it runs. It's usually an artifact that you wouldn't know what to expect, right? So if you have a large shift on your input, then your model is gonna be poorly performed. And
Yeah.
yeah, so I think this concept of MLOps, it's only a DevOps. Uh, it's a misunderstanding of this domain. So I try to work explaining why is it different and what are the concepts so you have to be doing as an MLOps engineer.
Interesting. So that's a good one. I like that. I think that sort of advocating for the uniqueness of data and parameters, as you say, affecting results in a way that's hard to estimate in advance and things like that is a good and concise way to sort of explain the difference. That's awesome. I like that. So thank you for sharing that. I guess before we wrap up, any recommendations you have for the audience? It can be related to machine learning, but it doesn't have to be. If you have shows on Netflix that you're watching and you recommend people see.
I'm a bit off. I have to admit I'm just now I'm watching Breaking Bad.
Nice.
After yeah, I don't know why I skipped that early days, but yeah, I'm deep into it right now. So it's a great show. I recommend if you have uh, I mean, only if you are tough enough you can watch it. Don't watch it if you're not used to seeing some
Yeah,
some hard stuff. Um, yeah, in terms of machine learning, I think as an MLOps engineer, push the boundaries, try to really get into machine learning, even though it's not your bread and butter as MLOps. Then understand what your data science team does, understand what is models, what is machine learning. I also did an online course on Coursera, um, to really try to practice and understand deeply what is machine learning and AI.
that's awesome. I agree with both recommendations. Even though I saw that there was a poll on Reddit the other day, and people thought that Breaking Bad is better than The Wire, which I very firmly disagree with. But both shows are very good, and I also agree on the idea of sort of looking beyond the role and understanding your users and things like that via doing courses. My recommendation on the cultural front is I finally finished reading the books of The Expanse. Where there was a TV series which is very, very good in my mind. It has 6 seasons, but there are 9 books, and the last 3 books are not overlapping, like or after what happens in the series. And I know I've recommended, like for people that are recurring audience members, I've recommended a bunch of sci-fi books on this show. I think
Mhm.
it's very good, and it probably has one of the best like series endings. So you're not, at least for me, I wasn't disappointed in the end. It doesn't have the problem
Okay.
that many sci-fi books have, where they get too philosophical in the end, and you don't really know what's going on with the plot because they want it to be really sci-fi-ish. So The
Mhm.
Expanse avoids that, which is great. And on the ML front, yeah, I concur with your recommendations. I'd say that if you're thinking about, as we mentioned, like LLMs and Gen AI and how things are changing in these days, I think that one interesting thing is that people, similar to how MLOps was, I don't know, 3-4 years ago, people really don't know how to do this. And so I think that there's a lot of interesting things that are happening. Things are changing fast, so you have to like the fast pace, even compared to regular ML. But there's a lot of
Mhm.
interesting things that are happening with respect to how do you utilize these models in production context and in real products. And so I think that tuning into the correct channels, there are a lot of great people to follow on Twitter and Threads now, which I guess is also a
Uh-huh.
recommendation.
Not yet there. Mhm.
Yeah, so I really recommend people look into this. And if you are trying to work on LLMs in a production context, don't take sort of anything for granted. Things are changing a lot, and people don't yet fully understand how it's going to look. Um, and last recommendation, as I mentioned earlier, probably by the time this is out, Data Engine is out, so check it out and give us your feedback because we really would like to hear it. And with that, Yuval, thank you very much for joining me today. It was awesome speaking with you.
Thank you. Great chat.
And thanks to the audience. I'll see you next time. Bye. Thank you for listening to the MLOps podcast. If you enjoyed this episode, please like the video or subscribe. If you have any feedback, leave a comment below. Thanks again for listening, and see you next time.